Welcome back to this week's Temp Tech Bite. Today we dive deep into the new scientific discovery coming out of the Glasgow University, which could be the key to unlocking unlimited energy from our universe. A 50-year-old theoretical process for extracting energy from a rotating black hole finally has experimental verification. Black holes are extraordinary chaos, the end stage of a life cycle of the star that is so massive, once it's gone supernova, its core can no longer withstand its own gravity and it collapses totally into a singularity, a single one-dimensional point of infinite density. This singularity sits inside a region called the event horizon, the point at which the gravity around the black hole is so strong that not even light speed is sufficient enough to escape its pull. Outside the event horizon lies an extended region called the ergosphere, where spacetime becomes twisted as it's dragged along with the black hole's rotation. The space in the ergosphere is elastic, meaning that particles inside of it will exchange their energy with it. This phenomena is called frame dragging, and it is the foundation of Roger Penrose's theory called the Penrose process, which proposes that a region just outside the event horizon, where frame dragging is at its strongest, could be exploited to extract energy. According to Penrose's calculations, if an object dropped into the ergosphere were to split in two, one part would be flung beyond the event horizon. The other, however, would be accelerated outwards with an additional kick from the black hole. If everything went just right, it would emerge from the ergosphere with around 21% more energy than it entered with. Unfortunately, we cannot just nip to a nearby black hole to test this theory, and so it's remained unproven for the last 50 years. This was until June this year, where a group of scientists from the University of Glasgow were able to test the Penrose process by probing a model black hole in laboratory settings. This was done by spinning a sound absorber foam disc incredibly fast and firing sound waves at the disc. These sound waves were then measured from the other side of the disc, with the confirmation of the Penrose process being a shift in the frequency and pitch of the sound waves. The twisted sound waves change their pitch when measured from a point of view of the rotating surface, explained physicist and astronomer Marion Crom of the University of Glasgow, lead author on the team's paper. If the surface rotates fast enough, then the sound frequency can do something very strange. It can go from a positive frequency to a negative one, and in doing so steal some energy from the rotation of the surface. The results of this experiment were amazing. As the disc's rotation accelerated, the pitch of the sound waves hitting the microphone lowered until it was inaudible. The team's next goal is to replicate these results with electromagnetic waves, providing undoubtful proof of the Penrose process. If successful, it could be a major stepping stone to harnessing unlimited energy for our planet. And that's it for this week's Temp Tech Bite. Please remember to like the video and subscribe to the channel. Check out our socials and head on over to our online store to see what's on offer. Thanks for watching, and we'll see you in the next one.